Chapter 9. Woo! That means the test is coming. This is 9.8 Part 2. We started 9.8 back when I wanted to teach you factoring by grouping. Now we're going to come back to 9.8 and talk about factoring completely. Okay? Up to this point, you've been dealing with factoring divided into sections. So each section you knew what you would be factoring. Now you're just going to be given a problem, and you're going to have to figure out which type of factoring you're going to have to use. Okay? Which, it becomes easier the more you practice it, but to help you get started out, I'm going to give you a list of things to start looking for and sort of a step-by-step plan that you can use to help you until you start knowing it by intuition. Okay, so step number 1, always look for a greatest common factor. Greatest common factor just makes factoring simpler. You pull out that common factor, it'll make the problem a lot simpler. So if you have a common factor among all the terms, make sure that you pull that out first. The second thing you want to do is look for your squares. So look for your difference of two squares or look for your perfect square trinomials. Remember we talked about yesterday about training your eye to start seeing those perfect squares. That just makes life a lot easier if you can notice those patterns right away, and then it'll just be a piece of cake factoring it. If none of those two things happen, then you're going to use your product sum factoring or your AC factoring. Okay? And then also again, if you have 4 terms, you're always going to use grouping. Okay? 4 terms and grouping go hand in hand. And again, just a reminder what we talked about yesterday, if you have 2 terms, you're either going to be doing only greatest common factor or difference of 2 squares. Okay, and this is strictly for 3 terms, the product sum and AC factoring. Okay, but 2 terms or GCF or difference of 2 squares, grouping is for 4 terms. Okay? Here we go. Factoring and solving. It will be so much fun. Okay, here we have n squared plus 2n minus 1. Step number 1, look for a greatest common factor. Do any of those share anything? The answer is no. Moving on. Are they perfect squares? No. Why? You may be saying to yourself, well yes, n squared is a perfect square, and yes, 1 is a perfect square, but the 1 has a negative in front of it, and you cannot take the same number and multiply it by itself and get a negative number. Because to get a negative 1, you would have to have a negative 1 times 1, and that is not a perfect square. Okay? So, that leaves us with product sum factoring. Because we have a coefficient of 1, we can just say what has a product of negative 1 that adds to positive 2. Well, the only things that multiply together to be negative 1 are negative 1 and 1. When you add those, we get 0. Does that equal 2? No. So this problem, tricky Miss Million, this problem is not factorable. Oh no. At least not until we get to Algebra 2 and learn about imaginary numbers. Or irrational numbers, either way. Okay, but yeah, this one's not going to work out so well because there is no product that has a sum of 2, so this one is not factorable. Done. Okay? Here, we have 3x cubed minus 12x. How many terms do I have? 2, which means I can use either greatest common factor or difference of 2 squares. First step is look for greatest common factor. Now your first warning going off in your brain is saying, hey, that's a cube. I don't know how to factor anything that has a cube. Okay, so when you see a cube, that means you're going to have to do greatest common factoring, at least at this point in life. Okay? So whenever you see a cube, always look for a greatest common factor, and you will always have a variable in that factor. Okay, so here we have 3x cubed minus 12x. These guys share a 3 and an x. When I pull out a 3 and an x from here, I am left with x squared minus, pull out a 3 from the 12, 4, the x goes outside, voila. Something should be going off in your brain right now. Ding, 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 ding. I see squares. Difference of 2 squares. If you saw that, you are correct. So, on the outside, I'm going to have this 3x. Here, what's being squared to get an x squared? You said x, you are correct. And what's being squared to get a 4? 2. And we have our little plus minus. equals 0. Now, here's something unique. We have three things being multiplied together. No worries. We treat it the exact same way as we would if we had two things being multiplied together. We take this and set it equal to 0, we take this and set it equal to 0, and we take this and set it equal to 0. So I'm going to have 3x equals 0, x plus 2 equals 0, and x minus 2 equals 0. Here, if I divide by 3, I get what? X equals 0. I'm going to put my answers right here. X equals 0 from there. That's one solution. Here, I'm going to subtract 2 to solve. When I subtract 2, that goes away, and I get x equals negative 2. And then here I add 2, so I'm going to get x equals positive 2. Those are my answers. I have 3. So should you. Okay? So we had a little bit of fun with greatest common factor, and we had a difference of 2 squares, and we had 3 products for our zero product property. You guys are going to be mathematical geniuses by the end of this video. Okay. Here, I have 3x cubed minus 18x squared equals negative 24x. First thing, we need to be set equal to 0. So, we're going to add 24x on both sides. Do I have any x's over here that I can combine with? No. These are not like terms, so we cannot combine them. So we're going to have 3x cubed plus 18x squared plus 24x equals 0. First thing, can we factor a cube? No, which means I look for greatest common factor. Okay, so all of these guys have an x, and they're all divisible by 3. So, again, I have 3x. When I pull out a 3x from this, I'm left with 1 and an x squared. When I pull out a 3 from here, 18 divided by 3 is 6. X squared divided by x is x. And here, 24 divided by 3 is 8. X divided by x is 1. Okay? Now, greatest common factor, check. Next on our list, perfect squares. Do we see perfect squares here? This is a perfect square. Is 8 a perfect square? No. Okay, we can't use trinomial here. So moving on, we're going to use our product sum. What multiplies together to be 8 that adds to 6? Well, for 8 we have 1 and 8. We also have 2 and 4. This guy is our winner. So this becomes our 3x has to stay. We have positive 2 and positive 4, so we're going to have x plus 2, x plus 4 equals 0. Okay? Again, I have 3 things being multiplied together, so I'm going to set 3x equals to 0, x plus 2 equals to 0, and x plus 4 equals 0. So this is going to give me x equals 0, this is going to give me x equals negative 2, and this is going to give me x equals negative 4. 3 answers again. Are you having as much fun as I am? I hope so. Okay, last example. What's going off in your brain right now? A cubed minus 11a squared minus 9a plus 99. Okay? If you saw the a cubed and something went off in your brain, good for you. If you saw the 4 terms and something went off in your brain, good for you. 4 terms means grouping. We're going to group these puppies and factor. Okay, what do these two have in common? Remember, we have to pull out the greatest common factor. So we're going to have an a squared, which if I pull out an a squared from a cubed, I'm left with an a, minus, this a squared is on the outside, 11. Okay? Note, this is a minus, this is a plus. I need the signs to be the same, therefore I'm going to pull out a negative something of this last one. Just so happens these guys share 9. If I pull out a negative 9 from here, I get positive a, and a negative 9 from here, I get minus 11 equals 0. Okay, these both share an a minus 11. And my leftovers are a squared minus 9. Oh my goodness! Difference of 2 squares. What are the chances? I know, you are loving this problem right now. Okay, difference of two squares is two brackets. What is being squared to get a squared? You said a. You are correct. What is being squared to get 9? 3. I do my little plus minus. Now I have three things multiplied together, so I'm going to set a minus 11 equal to 0, a plus 3 equal to 0, and a minus 3 equal to 0. This is going to give me a equals 11. This is going to give me a equals negative 3. And this is going to give me a equals positive 3. Okay? Don't worry, we'll be getting lots of practice of this in class. So when it comes to test time, you will all be factoring studs.